All right, beautiful. Now we are recording. All right. Full screen and then subtitles. All right. Okay, from here and on, this is the new stuff, right? Pay as much attention as you can, guys. Here we go.
So let's talk about conversion function. How do we go back and forth between polar coordinates?
All right, so that is today's topic. Changing or going back between one form of the point to the other form of the point. In other words, from polar coordinates to rectangular coordinates. That's what we're gonna do today, right? And this is how.
So what we'll do is we'll look at a point in the plane. We'll imagine that we've described both the Cartesian and polar coordinates for that point.
Profe, sube el volumen en YouTube. ¿Por qué le subiste el volumen al computador, pero no al video?
Thank you, Brian.
So here they are. How do
Let
we
me.
go back and forth between polar coordinates
There.
and Cartesian coordinates? So what we'll do is we'll look at a point in the plane and we will imagine that we've described both the Cartesian and polar coordinates for that point.
All right. So before we continue, right now, thank you for letting me know, Brian. Thank you. Before we continue, look at this drawing. I know some of you are not gonna get this drawing, and some of you are not gonna even care. But the people who like math are gonna go, all right, this is really interesting. And why is that? Because in just this drawing alone, I am showing you both definitions or ideas behind both coordinates. In this drawing alone, I am showing you that x and y are the distance in x and the distance in y. And those are the rectangular coordinates. But also I'm showing you that theta and r are the elevation and the hypotenuse, if we were to call it that way, of this triangle, which are the polar coordinates. So in this triangle alone, we can see the connection between rectangular coordinates and polar coordinates. And this is exactly what we're going to use to change between one coordinate to the other. This is how.
Here they are, x, y, r, and theta. Now we're going to use some simple right triangle trigonometry. The ratio x over r gives us cosine theta, and the quotient y over r gives us sine theta.
Did you guys remember this? This is a simple use of SOHCAHTOA, what you guys remember from 7th grade. Hopefully you guys remember from 7th grade, or maybe from 8th grade, or maybe from 9th grade from another subject, physics or whatever, right? SOHCAHTOA. Anybody? Anybody knows what is that?
Yeah, Mister, I remember it.
Thank you, brother. All right, can you tell us what is that? SOHCAHTOA, what is that?
So means that seno is equal to the opposite of the hypotenuse over the hypotenuse.
So
The,
sin equals
the
the
K
opposite.
means that the coseno is equal to the adjacent over the hypotenuse, and the TOA means that tangent is equal to the adjacent, is equal to seno sobre coseno.
All right, that's right. Tangent is sin over cosine. That is correct. But that's not the TOA part, right? That's not the TOA part, right? TOA part is that it is opposite over adjacent. Now, what you said is right. What you said is correct. Thank you, brother. What you said is correct, right? Tangent is sine over cosine, which makes me think that you guys remember this, right? I'm not showing you anything new, right? You guys know this stuff. All right, but just in case any of you don't remember this or don't really know this, I'm showing you anyways. So SOHCAHTOA is just a funny word to remember that sine, cosine, and theta are divisions, fractionaries, to call it that way, fractionaries in a right triangle, right? So the sine here, in case you didn't know, S is for sine, O is for opposite, H is for hypotenuse, right? And it works for everything else. C is for cosine, A is for adjacent, and H is for hypotenuse, right? We thought tangent, opposite, adjacent, right? Just in case you didn't know. All right. So if we apply, if we find the trigonometry, the right angle trigonometry to this triangle over here, if we apply these formulas, what we find is that cosine of theta will be, according to this, cosine of theta is the adjacent side over the hypotenuse. Okay, so if our angle is theta, the adjacent is x, right? And the hypotenuse is r, which is what we have here. Adjacent over hypotenuse, right? So we are, in fact, applying SOHCAHTOA to our triangle, right? But that works also with sine. That works with sine. Let me erase this. If we find the sine of the angle, again, we know just because of this, sine is opposite over hypotenuse. So this is opposite over hypotenuse, right? There is that, right? The opposite of the theta is y, and the hypotenuse is r. So look at that. Opposite over hypotenuse, y over r. So what we're doing here is taking advantage of our triangle to find some trigonometry. That is what we're doing here. Now, why is this important? Why did somebody in mathematics, some mathematician, decided to do this way? Why? Here's why. Let me erase all of this. We don't need this anymore. Here is why. Because if we isolate the variable x and the variable y, what we have is some formulas. That is what we have. Look at this. Take a look at this. We are going to multiply on both sides of the equation by r. R and r, right? And if I do that, this is what's going to happen. Look at this. We're going to cancel this with this, cancel this with this. And now, in one side of the equation, we only have the x or the y. Somebody in the chat is saying something. Samuel Mendez says, adjacent is the opposite of the hypotenuse. No. No, paso un momentico al español para que se entienda mejor. ¿Listo? No, no lo veas así. No lo veas así. Miremos qué significa adyacente. Si vas al libro, a un diccionario más bien, si vas a un diccionario y buscas qué es adyacente, adyacente significa que esté al lado de. ¿Listo? Entonces, algo que esté al lado de es algo que está adyacente. ¿Hasta ahí vamos bien? Ok, entonces, mirando este ángulo que está aquí, hay dos lados adyacentes a él. Hay dos lados cerquita, pegaditos. Esa es la idea de adyacente, que estén al lado. ¿Cuáles son esos dos lados? Bueno, pues tenemos el primero. Este es el primer lado que está adyacente a él. Pero también está este otro lado. ¿Sí o no? Hay dos lados adyacentes al ángulo. Hay dos lados adyacentes al ángulo. Ok, entonces, ¿cuál de los dos llamamos adyacente? Bueno, pues resulta que solo uno de esos dos tiene un nombre diferente. Ambos son adyacentes. Ambos son que están al lado del ángulo. Pero uno de esos dos tiene un nombre diferente. Uno de esos dos se llama hipotenusa. La hipotenusa es el lado más largo. Ahora, esto solo funciona si el triángulo es rectángulo. Si el triángulo no es rectángulo, por ejemplo, que voy a hacer aquí a continuación, suponiendo que esté recto, porque si no, no es un triángulo, suponiendo que esa recta que es recta, este triángulo que hago a continuación, ese triángulo no es un triángulo rectángulo. Aquí no podemos mirar cuál es la hipotenusa. Aquí no hay hipotenusa. La palabra hipotenusa hace referencia a el lado más largo, pero solo cuando estamos hablando de un triángulo rectángulo. ¿Ok? Entonces miremos, regresemos. ¿Cuál de los dos es el adyacente? ¿Este es el adyacente o este es el adyacente? Bueno, pues este no puede ser el adyacente porque yo sé que hay tres palabras claves que tengo que aprenderme. Una es adyacente, otra es opuesto y la tercera es hipotenusa. ¿Ok? Y si este de aquí es la hipotenusa, pues por proceso de eliminación esta tiene que ser la adyacente. ¿Sí la viste? Aprenderlo como lo estás diciendo podría funcionar, aunque de pronto si cambiamos de lado el triángulo ya no funciona. ¿Por qué lo digo? Si decimos que adyacente es el que está opuesto a la hipotenusa, esto podría pasar. Opuesto a la hipotenusa, o sea, el lado opuesto a este, pues puede ser opuesto a este, puede ser este lado o puede ser este. Ambos están opuestos. ¿Sí o no? Entonces ambos podrían ser el adyacente y este de acá no es el adyacente. Entonces no es una buena manera de aprendérselo así. ¿Listo? Si yo cambio de dirección el triángulo, inmediatamente nos puede pasar ese error que estoy diciendo. Inmediatamente. ¿Ok? Ahora, ¿por qué es mejor aprenderlo como lo digo? Porque resulta que estos trigonometric ratios dependen del ángulo. Aquí estamos analizando este angulito de acá, este, teta, este. Pero bien podríamos elegir otro. Bien podríamos elegir este angulito ahora, este de acá. Este. Y ahora el opuesto y el adyacente cambian. El opuesto antes, este era el opuesto, ¿verdad? Pero el opuesto para este ángulo no es este, el opuesto es el que está al frente. O sea que ahora este es el opuesto. ¿Cómo así tenemos dos opuestos? No. Opuesto y adyacente cambian dependiendo del ángulo que estamos mirando. Por eso es importantísimo tener en cuenta lo que acabo de decir. ¿Listo? Entonces, Samuel, ¿mejor?
Sí, gracias, profe.
Con muchísimo gusto, mi hermano. Mis niños, mira cómo Samuel me preguntó algo que suponíamos que hablábamos de séptimos, suponíamos que sabíamos, pero si ustedes siguen suponiendo, si ustedes siguen aceptando lo que yo supongo, vamos a seguir teniendo errores. Samuel, bien por haberme preguntado, papá. Mis niños, cualquier persona que tenga errores, dificultades o preguntas sobre este tema, hágala de una para que yo les pueda ayudar. ¿Está bien, mis niños? Sin miedo. Sin miedo. Porque si no, pues seguimos con los mismos errores y ya está, pues no seguimos aprendiendo. Muchas personas que perdieron matemáticas en sexto, séptimo y octavo van a perder matemáticas en noveno y van a perder matemáticas en décimo y van a perder matemáticas en 11. ¿Por qué? Pues porque con las bases es que construimos. Y si perdiste en las anteriores materias, si perdiste en los anteriores años, perdón, sexto, séptimo y octavo, probablemente tienes malas bases y seguirás perdiendo. ¿Cómo lo solucionamos? Pues preguntándole al profesor, oiga, profe, en sexto no entendí esto, me explica. Y yo con muchísimo gusto, mis niños. All right, so let's get back to the class. Let me erase this. Okay. So now, if we isolate the variable x and the variable y, what we have are formulas. Take a look at these.
So here we have simple equations which allow us to move from polar to Cartesian coordinates. If we know r and theta, we can quickly generate the values of x and y that describe the same point.
All right. So what the guy is saying here now is that these two, which again were the result of isolating x and y, these two are our formulas, conversion formulas to change from polar to Cartesian. And that is exactly what we're going to do today. We're going to use these two formulas. What do we know? What do we need? Sorry, we need the values of r and theta. In other words, we need the coordinates of the polar coordinates to change to Cartesian or rectangular. All right. The easiest way to apply what we just learned is with some examples. So let's do the first one. This is going to be our first example. This is a polar coordinate. 6, pi over 6. How do we change this polar coordinate into a rectangular coordinate? That is the question here. Find the rectangular coordinates of the points with the following polar coordinates. So I'm giving you the polar, you need to find the rectangular. But how? Okay, the first thing I would do is plot the point. If I plot it, it will give me ideas on what are the other coordinates. Look, plotting this 6, pi over 6 means an elevation of 30 degrees, right? Because pi over 6 is 30 degrees. And then a distance from the origin of 6. So this is the point, right? And just by looking at the point, we can kind of speculate the value of 5, right? The value of x, sorry, not 5, but the value of x. Our x variable will be close to 5. Look, 5 point something. Did you see? So plotting the point gives us ideas of what are the other coordinates. And for y, it looks like, from my drawing, it looks like the y coordinate is exactly 3. Now, we cannot be sure just by looking at these. Maybe the drawing is 3.1, right? The coordinate is 3.1, or maybe it's 2.9, right? But it gives us some ideas. All right. How can we make sure? By looking at the formulas. So since the point is in the first quadrant, we know that the x variable and the y variable, the x and y coordinates, have to be positive both, right? This is the x, which is positive, and this is the y, which is positive, right? So we know those variables with those numbers, have to be positive, right? To find the precise answer, just use the formulas. We know that r equals 6 and theta equals pi over 6. These are the values here. If we replace them in the formulas, this is what we get. Instead of r, 6. Instead of theta, pi over 6. All right, then, how do we solve this now? Well, we just put it in a calculator, and that's it. Cosine of pi over 6 in a calculator will give us 0.866. Again, this part is done with a calculator. Let me write that in here. This part here is done with a calculator. I just took the cosine of pi over 6, you put it in the calculator, right? And the result give me 0.866. Right? That is what I did. Now, what about the 6? Where did the 6 come from? Remember, this value of 6, I didn't do anything with it. All I did was putting cosine of pi over 6 in the calculator. The 6, I didn't do nothing with that. The 6, I just move it on the other line. Now I have to multiply, right? Now the 6 is this r over here. This is the measure of r, right? Now, once I do that, if I multiply this, I know that the answer will be 5.196. In other words, around 5.2. And it makes sense. Look at the drawing. We plotted at the beginning. It makes sense, right? Wait. Look at the value of our x coordinate. Our x coordinate was 5 point something. Where we're looking at the result, it is 5.2, around 5.2. So it looks like we are doing things correctly. Right? Now, for y, we just use the same, the other formula, the formula for y, and replace the values. Instead of r, 6, and instead of theta, pi over 6. Put this in a calculator, and again, if we do it step by step, we're going to have that sine of pi over 6 is exactly 1/2. You can check this with your calculator. So now, pi over 6 becomes 1/2. And if we multiply the 1/2 by 6, this is 3. Which again makes sense, because look at that. The coordinate of y, the y coordinate, looked like it was 3. Huh? A couple of things before we move on. I just want your attention here. Look at this. Sometimes I use the equal sign. Look, equal. And some other times I use the round sign. Why is that? Okay, the reason for that is because the moment I use cosine of pi over 6 as this decimal, the moment I change that for this decimal, I am doing a rounding. The answer is not precise here. The answer is a round number, right? If you do this in your calculator, you're going to find that 0.866 has a lot more decimals. 0.866 and then some other numbers. So I'm rounding this number to 3 decimals. Since I am rounding, I need to use the symbol for rounding, right? And this multiplication is exactly this, but it comes from a rounding. So I also have to use the round here. Instead of in this case, look, sine of pi over 6 is exactly 1/2. If you do it in the calculator, it will give you exactly 1/2. Or maybe 0.5, right? Okay, so I don't have to round in here. I just use the equal sign. All right, guys, cool. Thank you. All right. How do you write the answer now? How do you write the answer now? Pretty simple. Here is the answer in red. Since we are talking about coordinates, we need to write the answer as coordinates. 5.2, 3. This is the value of x. This is the value of y. Remember, these are coordinates, so inside or between parentheses. That's it, guys. Let's move into another example. What do we do when we have the two values negative? R and theta are both negative. How do we do it in here? Simple. First, plot it. Always, guys, plot it first. Again, some of you are just gonna jump into the equations. That's okay. Some of you are gonna do it, but you guys are not gonna know if the calculator is showing you a mistake. I'm gonna show you in a minute how sometimes my calculator shows me mistakes, and it could happen to you. So plotting the point assures you if you're doing things right or not. Okay, so an angle of negative pi over 4 means an angle of negative 45, means this over here, right? Negative, under the line, negative. This should be the direction, so I have a 4 here. This should be the direction if I measure 4, but I want to measure negative 4, so I'm going to measure it in the opposite direction. There, negative 4. This is the location of the point. And from this location, I know that it lies on the second quadrant of the plane, meaning I have a negative value of x and a positive value of y, right? Actually, I can kind of see that the value of x is negative 2 point something, 0.9, 0.8, point something that is really close to negative 3. Did you see? Same here. The value of y is 2 point something, maybe 2.9, maybe 2.8, something really close to 3. All right, let's look at the formulas now. Replacing the values of r and theta in the formulas is going to give us negative 4 times the cosine of negative pi over 4. Right? Doing this in the calculator, it's going to give us the result. Again, we are rounding, so we use the symbol for round. Multiplying by negative 4, we have our solution now. Negative 2.828. So, as we said at the beginning, negative 2.8 and negative 2.8 around here. Pretty good. Now for y. Y equals r sine of theta. Y equals negative 4 sine negative pi over 4. This is a simple replacement. Again, I am replacing the values of r and the values of theta. From here, put this inside as a calculator and get the result, 2.828. So as I said at the beginning, around here is 2.8 or 2.9. So we know 2.8. We did things correctly. The result, inside parentheses, negative 2.8, comma 2.8. And that is it, guys. That is how we change from polar to rectangular. That is it, guys. Now, before we continue, I want to show you in my calculator how sometimes my calculator gives mistakes. All right, let me show you this. All right, so let's say I want to calculate cosine of negative pi over 4. Let's say I want to do that. So I just do cosine. Guys, instead of pi, don't ever use 3.14. That is a mistake, all right? Don't ever do that, guys, please. Cosine of negative pi, look, it's right here. Second and this key. It is right there. Pi. Pi divided by 4. Pi over 4. Okay, if I press enter, this is the result. 0.9999960. All right, that is the result. But that is not what I have. That is not what I have. So what is going on? Look, according to my example, the result should be 0.707. This should be the result. So what happened? What happened? All right. Even if I took that number and multiply by negative 4, look, negative 4 multiplied by the answer we just got. So now I'm doing negative 4 times this. That's what I'm doing right there. If I do that, the result should be Negative 3.999. So really close to negative 4. And it doesn't make sense because look at our picture. If we look at our graph, our picture, the result should be negative 2 point something. Why is it so close to negative 4? This is a clear mistake, guys. This is exactly why I'm telling you to please plot the points before we jump into the exercises. Before. Right? Now, my problem here is a simple problem of measurement. Look, the process that I'm doing is cosine of a radians, right? The angle is in radians. So I'm doing cosine of radians, right? But my calculator is accepting degrees only. My calculator is accepting degrees. And you can see that in here. Look, if I press the mode key, again, mode, you can see that right where it says here, radians or degrees, right in this line, radians or degrees, I am located in the degrees option. So it makes sense that my calculator is not calculating properly because I introduce a radians when the calculator is expecting degrees. Did you see? So I have two options. Number one, I have two options. Instead of doing cosine of pi over 4, I can do cosine of negative, this is not the negative, cosine of negative 45. This is pi over 4 cosine of, I'm sorry, this is pi over 4, 45, right? So if I press that, the result is now correct. 0.707, what I had. So again, my calculator is expecting degrees, so I should enter degrees. That is option number one. Option two, tell the calculator to accept whatever I am introducing. So if I want to introduce pi over 4 because I'm lazy and I don't want to do the change to degrees, if I want to do that, I'll simply go down and click on radians right there. Now the calculator is highlighting radians. So now the calculator is expecting radians. So now if I do cosine of negative pi over 4, if I do that, now the result is exactly the same as before. Now the result is correct. So guys, please, if you're gonna take something from today, make sure your calculator is in the proper measurement. Not always has to be in radians, not always has to be in degrees. All right? You guys decide that. Beautiful. That is it for today, guys. So let's go into the exercises. These are the exercises I want you to do. Exercises 39 to 54 from the page 726. We only have 15 minutes to the lunch, but I still want to see you working, guys. We are not going to go to lunch right now. We are going to work on this even for these 15 minutes, all right? I'm going to stop the recording now, and let's get to work.